Alright, this is Tesla's wireless system. I started doing experiments with the basic mini ones that I got set up, and I've gotten good results, you know, because he's right. But so I'm using two mini type Tesla coils that I'm trying not to have any type of sparks come off or anything, and this also is going to prove one wire transmission. It's not too it's pretty good with one wire. So this is how it's set up. I have power coming in. Power goes to a 6,000 volt transformer. The transformer is sent through like a little mini spark gap right here, and that spark gap is going to the primary, she says the secondary capacitive top, and then the energy will be sent through this thin little wire right here, and it's all connected, and it's connected all the way to the other one. And the other one's the same thing, except instead of putting power out, it's absorbing the power. So the energy is going into the secondary, and then the primary is making it more of a current instead of voltages, so it can push and, you know, make things move. And so this is the one wire transmission principle, because we're only using one wire to send energy to another point, which is friggin' awesome, because, you know, there's no, you know, they always say it has to be a closed system, and in this we're making energy go through one wire, go to the other side, and light up some things. Let's see, what else I gotta say. So I'll do a demonstration of this. And so the capacitive tops, they do matter. If you take it off, there's a difference in potential, and that even with the receiving one. And look, they're not even the same size, so it's not going to be perfect resonance, but there is energy there. So I've gotten this little graph here to show you, which is just like what I was saying. The transformer, the little spark gap, the primary, the secondary, capacitive top, secondary wire to another secondary wire that goes to the secondary coil, which then pushes the energy back down to current, and then I have a meter to show the energy. And so in this I've gotten 20 amps coming through the wire, and the voltage is between 100 and 150 volts, which is kind of cool because we're only putting 120 volts in. So I was like, what the hell? So yeah, the voltage now when I connect stuff to this, it doesn't really show the true amount, but there is energy. Like I can light up the LEDs and everything, and it's really interesting. I don't have a capacitor here because I didn't have the right ones, but I used the spark gap and I twisted it in a weird corona purple color goes around it, like a plasma, and the plasma, it's like almost like a capacitor effect. Like the spark gap's there, but it's not sparking, but there's this like plasma cloud that forms, and it's pretty cool looking. Alright, I'm going to give you a demonstration of one wire transmission 100 years later, and yeah, so I'm going to turn this thing on, and you'll see the cool plasma effect off of that. Look how cool that is. And now look, you look to the middle, shoot, see that? That's electricity jumping between one wire. And now if we go over to this, look, the LEDs are lighting up. Uh-oh, one wire transmission. So yeah, the energy's flowing through one wire to the other coil, and it's demonstrating Tesla's principle of one wire transmission. He ended up using this principle in a large scale for the whole world transmission. But as you can see, both LEDs are lit up, one wire, and everything's dead.